This is now take 3 on this video, so if I go through it a little fast, I apologize. Well, I've created a system of equations. A system of inequalities. It's not equations because we don't have equal signs. We have greater than and then less than or equal to. So that's a system. A system is multiple things combining together to make one unit or one entity. We talked about in class a PlayStation system. That's made up of multiple controllers, power cord, a console, all kind of different things. But it's one unit that works all together. And system of equations, or inequalities, I should say, means you have multiple inequalities. We really only have to deal with two inequalities. But we're going to just get one solution. We're just going to get one value for x and one value for y. We're not going to have two different values of x and two different values of y's, even though we have two different x's. So anyway, I'm going to start with the bottom equation. It's already set up for me to use the y-intercept and the rise over the run. The y is all by itself. That's what makes it slope-intercept form. Right? So y is all by itself. There's a rate of change times the x, and then I have a number all by itself, which is my y-intercept. So I simply start at the y-intercept, which is the last part, -5. I forget the negative part. Boy, this pen is not writing where I want it to write. Try that again. I guess that's going to do. So there's my y-intercept. I plotted it. It's hard to see. You'll see it in a second. Now, from there, my next step is I need to take the rate of change, which is the 6. It is not 6x. It's just the 6. Write it down here, and then write it over 1. A lot of you are putting the 1 up where the 6x is. If you understand, then I guess that's okay. But the problem is if you put it up there, you can't write rise and then run next to it, which some people are making mistakes when they're doing this. They're going in the wrong direction. So anyway, I'll leave that up to you guys. I would write it down here just like I did. So from the -5, so from the red coordinate that I drew on the plane, on the coordinate plane down below with the -5s, I need to count up 6 spaces because my rise is 6. That means I go up 6. If it would have been a negative number, I would have had to have gone down because it's always up or down for your rise. It does not mean that I go from this point out to this point where 6 is. I still have a lot of people doing that. Does not mean that. It means that I need to count up from the -5 6 spaces. So if I go 1, 2, 3, 4, 5, 6 from -5, it takes me all the way up to where the 1 is, +1. From that +1, I need to count to the right 1 space because I go to where it says, because the run is +1, which means I go to the right 1. So again, I'm counting all the way up to here and over to here. Up 6, over 1. So I just put my dot. Once I've done that, I put my dot right there. So now, you can barely see it, but that's going to be fine. So I'm going to draw the line through it anyway. I really just need those 2 points to make the line. So this line is slightly off. I'll shift it over in just a second. There we go. So now that's my line. Like I said, I'm going to drag it over just a little bit so that it's more on the 2 points. I'm also going to extend it through the 2 points a little bit. It should go. Your line should always go all the way across your graph when you're doing inequalities. Because remember, you're going to wind up shading one side of it. If you don't send it all the way through the graph, it's hard to just tell where you're supposed to shade. Okay, so I've created my line. My next step is I need to determine, is this line going to be a dashed line or a solid line? The way that I do that is I look at the symbol right here. Whoops. If it has an equal sign in it, if part of it, so this is less than or equal to, That means the line needs to stay solid because all of the points on the line are part of the solution set. So in this case, it's going to stay solid, so I don't have to change anything about that. So my last step is I just need to shade. I just need to shade the correct side of the line. Now, if you remember this and if you understand it from class, I know immediately that it says y has to be less than or equal to my line. Less than or equal to means all of the y coordinates need to be below the line. So for example, if this is my, you see where my line is, above the line would be on this side. All of this is above the line. All of this is below the line. Because again, these points are below the line. The y values are below the line. If you don't get that, then don't worry about it. Some of you did, some of you didn't. It's not a big deal. Here's what you do if you don't get that. All I do is I just plug in a coordinate. So I always test 0, 0. And I just say, okay, well, if 0, 0 is my test coordinate, that's going to be my x and that's going to be my y. I just plug those values in into this equation. So I say, okay, well, y becomes 0, which needs to be less than or equal to 6 times 0, so 5. I do the math, that goes to 0, and I get 0 is less than or equal to negative 5. Then I say, is that true? No, that is not true. 0 is not less than or equal to negative 5. So that means this side where 0, 0 is, where I have that little dot, that is not the solution side because it didn't prove the equation true. So that means that my other side is my solution side. So I come over here, I'm going to use yellow, and I highlight this side because that has to be the solution side. And I don't have time-lapse video, or I wouldn't make you watch all of this. But as we discussed in class, this is kind of fun. It's a stress reliever sometimes in class. Maybe one day we'll just all color on the whiteboard, smartboards. All right, so I've colored all of that in. One line done, line completed, and shaded. Now I'm going to go ahead and get rid of all of this text right here, or all of this work that I just did. So I'm going to get rid of all of that. I did one line. It's going to be a little tough to get rid of this, but I'll do my best. That's close enough. Actually, can I just, oh shoot, you know, I can erase right over that since I typed in. All right, so next, I need to do the equation that is in blue. So I'm going to switch over to my pen, make it blue ink. It's still, oh no, for some reason a different one. So now this one is not set up with y all by itself. So I cannot, mess that up. So I had to do that again. I cannot just do the rise and the run and the y-intercept. I have to do the other method, which means I'm going to have to actually solve out and get 2 coordinate points and plot both of those points and then connect them. We've done this in class, so I'm just going to go through it. So I take this equation, 1.5x subtract 3y is greater than negative 3, and I'm going to first make x equal 0. So if I do that, then I just take out the x and I put 0 there. So 1.5 times 0 subtract 3y is greater than negative 3. So this all goes to 0. That's the whole reason why I picked 0, 0 as my point, not 0, 0, but I make x 0. So I get negative 3y is greater than negative 3. You have to divide by negative 3. Don't forget to include that negative sign. You can't just forget about that. That means I divide by negative 3 over here, and I get y is greater than 1. So basically my point, my first point, coordinate over here, x was 0 because I made it equal to 0 up here at the beginning, and then y is 1. So now I'm just going to plot that point. So I get right here, so that is 0, 1. right there. Right, so now I could pick any other point. I could pick any other x value I wanted. If I wanted, I could pick x equals 0, x equals 1, x equals 2, x equals 3. We could pick x equals 10, x equals negative 2, and then I could solve for y, and I would have a second point. Any of those points, though, in my math becomes a little tougher. So instead of picking another x point, I'm just going to pick y equals 0. Because again, that makes my math easier. When I plug, so I get 1.5x, subtract 3, but now instead of times y, it's times 0, because I'm making y equal to 0. And that's going to be greater than negative 3. So again, the only thing that changed is I replaced the y in the original equation with 0. That's the only thing that changed. Everything else is the same. So now I do the math. That all cancels out. Negative 3 times 0 becomes 0. So I'm just left with 1.5. 1.5x is greater than negative 3. I need to divide through by 1. This is not negative for some reason. It's driving me crazy. So I divide through by negative, or I'm sorry, not negative, 1.5. And then I have to divide through over here by 1.5. And if I do that, then I get x is greater than 1.5 is in that 2. X is greater than 2. So anyway, I'm sorry, x is greater than negative 2 because I have a negative 3 divided by a positive 1.5. So x is greater than negative 2, which means my point is negative 2, 0. Because again, I made y equal to 0 at the beginning of this right here. So now I just need to plot that point. So I go to negative 2, 0. Oops. Negative 2, 0 right there. Now I'm just going to draw the line that connects those 2 points. It's blue now. So I come over here and I say, draw through those 2 points. I'll extend the line all the way across the graph like I told you to do. And my last, I need to determine, is that a dashed line or is that a solid line? Well, in this case, my symbol is only a greater than. There's no equal to part to that symbol. So if that's the case, I need to change to a dashed line. This is not going to be a solid line this time. So I need to change that to a dashed line. So I've changed it to a dashed line. And now my last step is I need to decide which side am I going to highlight. Shadow. I'm sorry, shade. Actually, I need to change that. Okay. The only way to do this, really, when you have an equation that's in this format, right here, where y is not by itself, the only way to do it, really, is you just need to plug a point in. So again, I'm going to test 0, 0, right there. So if I test 0, 0, my x value becomes 0, so I've got to separate this section. 1.5 times 0, subtract 3 times 0 should be greater than negative 3. So it should be greater than negative 3. So I get, so that just goes to 0. That just goes to 0. So I get 0 subtract 0 should be greater than negative 3. 0 should be greater than negative 3. Well, yes, 0 is greater than negative 3. So that means I need to include this point 0, 0 as part of my solution. So I'm going to shade the side where I have that 0, 0 ordered pair included in my shaded region. So change to blue, so that means I'm shading this side. And we're gonna, again, see some science here where yellow and blue make green. And yellow and blue make green, yellow and blue make green. So let's go over what this graph means real quick, just to wrap it up. So we've created both lines. We checked to see if the lines are solid or dashed. We did a test to see which side we should shade, and now we've shaded. So what you're going to notice is you kind of have 4 distinct regions of this graph. You have one section where you only have blue right here. You have one section where you only have yellow right here. You have one section where you have green, which basically means you had yellow and blue together. This section was shaded yellow and it was shaded blue. Then you have one section over here where you don't have any shading at all. So there's 4 distinct sections. We haven't really talked about this in every class. Here's what those sections mean. The section in blue means that we satisfied one of the 2 equations. Not both of them, but one of the 2. So in this case, we satisfied the equation that is in blue up here. So that blue area only meets the top equation. The area in yellow only meets the bottom equation right here. So those values of y are less than and equal to the 6x subtract 5, but they don't satisfy the other equation, the top equation. These values satisfy both equations. That's what the green means. That's kind of our solution. All of those values work for both equations. If we plugged in any coordinate point in that little black box that I just put, if we picked any of those, they would work in both equations. And then lastly, this section right here, all in white, this section doesn't satisfy any of the equations. So any point in this white section wouldn't work for any equation. So for example, if I picked -1 and then 2, so this point right here, if I picked -1, 2, I plugged it into either equation, it wouldn't work for either. So I'll just show you that. So 2 is my y value, -1 is my x value, so that's supposed to be less than or equal to 6 times -1 subtract 5. So 2 is not less than or equal to, that'd be -11. 2 is greater than -11. So see, it didn't work. Now if I plugged it in for the top equation, and if all of this is getting more confusing, you need to keep watching. It's just for you people. I'm going to try to go a little deeper. If I plug it into the top equation, again, I'm testing -1, 2. So I would say, okay, well, 1.5 times -1. I'm tracing this area right here. And then I would say subtract 3 times 2, because that was my y value, should be greater than -3. Let's see. 1.5 times -1 is -1.5. Subtract -3 times 2, so it would be subtract 6. Subtract 6 greater than -3. Well, this comes out to be -7.5. -7.5 is not greater than -3. So again, this point right here that I just tested does not work for either equation, which is exactly what we should have come up with because there's no shading there at all. No shading means it didn't work for either equation. Green shading, which is actually technically yellow and blue, means it works for both equations. And then if you just have yellow or if you just have blue, that means they only work for one equation. And in this particular case, the blue only worked for the top equation. The yellow only worked for the bottom equation, the red equation.